Okay, we're going to look at a different way of measuring angles, so using radians rather than degrees. So we're going back to trigonometry. I'm going to go back over the stuff we did before, but answering the questions in radians, so it'd be a good bit of revision for you. And then we need to look at area of a sector and arc length in radians and associated questions as well. To start with, if we think about y 360 degrees just for a minute, I'd much rather be doing this in class with you. So 360 degrees seems a bit of a weird number to divide a circle into, especially in a decimal system that we're now in. Some people believe that there's approximately 360 days in a year, which I don't believe is the case, but you will find some books state that. If you go back to Babylonian times, which is like 1700 BC, they used a number system which was fundamentally base 60. And the reason why they used base 60 was because you can divide it in lots of different ways. So you can divide 60 by lots of different numbers, so you can split it in lots of different ways. So it's a very useful rudimentary number base. And that has stuck around to this present day. The other place you'll see base 60 still being used as time, and it feels weird. It's like, why haven't we put it into a decimal system? But actually we can split 60 in lots of different ways. And I think that's the reason why it still exists. We obviously use base 10. I would have liked you to think about why base 10, but literally it's because we have 10 fingers. There's no other reason why you would choose base 10 as a number system. So that's why we've ended up with base 10. It's not some magical system. It's just quite practical for counting on your fingers. Yeah. So this is a remnant from thousands of years ago. So what we're going to do now is introduce radians, which as you get into pure maths, you don't use degrees, you use radians because they're much more mathematical, but not so good for everyday life. So the other way of measuring angles is gradient, which I think is when you split a right angle to 100 degrees. So on your calculator you will see that as well, but we don't work with that at all. Right, if you've got a sector and the radius is r, and this arc length here is also r, then this angle here is 1 radian. So theta is equal to 1 radian. There is notation for radian, but it just doesn't get used in A-level maths, but it's a little c like so, but you won't see it being used, and doesn't look dissimilar to the symbol for degrees, but anyway, I'll talk you through that as we go. So the number of radians in a circle actually we do a couple more of these. If I extend this out, so you've got R, and 2R, then that there is 2 radians. I'll use a little c, it's probably the only time I'm actually going to use it. And then you could go again, and R and 3R. So when you swing all the way around, then the distance all the way around here is 2 pi r, and that will give you 2 pi radians. So you're basically doing circumference divided by radius. So we end up with 2 pi r divided by r. So here I've got 2r divided by r gives me 2 radians. And you could just keep that going as you swing around the circle. And so the number of radians in the circle is 2 pi. So it follows that, need a clean board. So 360 degrees is 2 pi radians. You can see why we don't use these in everyday life. But they're much better for use in maths, as you'll see as we go through this next year actually. 180 degrees is pi radians. You'll get used to this quite quickly actually. 90 degrees is pi by 2 radians, etc. So the main angles you'll just kind of start to think in radians. It takes a little while. I've always weighed myself in stone, and I can't think in kilograms very well with people's weight. So it's the same sort of thing, but the more you use a new unit, the easier it becomes. To convert degrees to radians, this is probably the most useful thing, especially at the beginning. You times by pi over 180. So for instance, 18 degrees in radians is equal to 18 times pi over 180, which is pi by 12. Right. It's pi by 10, isn't it? Oh, it's because I've got 15 written there and I've got 18 written here. I was starting to doubt my adding up quite drastically there. So that's pi by 10. And when you see an angle with pi in it, then you can assume it's in radians. So use of pi implies radians. So that's why you don't need to do this little symbol with a C, because you know it's radians because it's got a pi in it. And then to convert radians to degrees, you do the opposite. You times by 180 and you divide by pi. So you can see that from up here. So pi by 4 in degrees is equal to pi by 4 times 180 over pi. Pi's will cancel off. 184 over 4 is 45 degrees. So that's your kind of little learning point there. And 360 degrees, 2 pi radians, 180 degrees, pi radians, etc.